Okay, so today we're diving into the world of web scraping
Web scraping, yeah.
using Ruby.
With Ruby, that's right.
Specifically, we're going to be looking at this article called "Modern Guide to Web Scraping with Ruby: Advanced Techniques and Best Practices for 2025."
That's a mouthful.
Yeah, it is for 2025, so pretty forward-looking.
It is. And, for anyone listening who maybe has never even heard of web scraping, can you give us that quick, sort of elevator pitch of what web scraping even is?
Yeah, so you're browsing the web and you see some information, maybe it's product prices, maybe it's sports scores or really anything. Web scraping is automating getting that information without you having to manually copy and paste it. So imagine like having a super powered copy and paste that can just grab, specific pieces of data from tons of different web pages all at once. I like that. A super powered copy and paste. Now the article we're looking at, it actually uses Ruby, which some people might think is a little bit, I don't know, maybe not the most obvious choice in 2025, but this article makes the case that it's actually still a really great option.
Yeah, I mean, Ruby's been around for a while now, and it's known for being a really pleasant language to work with and really powerful, and that's still the case today.
Uh-huh.
And for web scraping, it's got some really great tools and libraries that can make the whole process a lot smoother.
And so this deep dive, what we really want to do is uncover, what are those, really key advancements in techniques and, smart ways to scrape the web today, and also get a feel for, okay, where does Ruby sit within, the larger landscape of software development, all without, getting too bogged down in, every line of code. We want to keep this high level.
Yeah, absolutely. We want to extract the insights, not necessarily become web scraping experts overnight.
Exactly. So I guess, jumping right into it, what were some of those core insights from this modern guide to Ruby web scraping?
Okay, so one of the big takeaways right off the bat is that, despite everything new that's out there, Ruby is still holding its own in the web scraping world. And the big part of that is because of its really powerful gems, which is what Ruby calls its libraries.
Mhm.
So, things like no-code which is fantastic for understanding the structure of web pages, which is HTML, and then there's HTTP party. That one lets you make those initial requests, to actually fetch the content you're after.
Right. And so for anyone who's never done web scraping before, just to clarify, it's not like you just point, your code at a website and say, give me everything. You actually have to understand the structure of those pages, right?
Absolutely. That's where no-code comes in. It lets you kind of slice and dice the HTML, pick out specific elements, titles, prices, whatever you need.
Yeah, and this is one of those things where it's almost like learning another language, right? Even though it's, something visual that we all see on the web, there's, code underneath all of that.
Definitely. It's like learning the secret language of the web.
Exactly. Now, the guide also points out that it's not enough to just be able to grab the data anymore. It's become a lot more, kind of strategic, right? Like you were saying earlier, there's this whole element of how you make those requests to websites.
It's a little bit of a cat and mouse game. Yeah.
It is.
Websites are getting smarter at detecting and blocking bots, the automated programs trying to access their data.
Yeah.
So you need to be careful about how you're making those requests, not just bombarding the website, with tons of requests all at once.
Yeah. And the article mentions proxies too, right? So
Yeah.
I think, for people who might not be familiar with proxies, it's basically, having your requests go through another server first.
Well, it's like having a middleman. So instead of the website seeing your IP address, they see the proxy server's IP address. This can help you to, spread your requests out, make them look more like they're coming from different users.
So it's like not having all your eggs in one basket.
Exactly.
Oh, yeah.
And it also mentions rate limiting, which is the idea of deliberately pausing between requests, not sending too many at once so that you don't trip any alarms on the website.
So it's almost like, being a good citizen of the web, not trying to overload anybody's servers.
Yeah, being respectful, basically.
And the article also highlighted, handling errors gracefully, right?
And
So if something goes wrong, your code doesn't just, completely fall apart. You can kind of anticipate those problems and deal with them in a smarter way.
Exactly. And then there's this idea of, when you're dealing with lots and lots of data, really large websites, doing things concurrently becomes really important. And that basically means having multiple parts of your code working on different pieces of the problem all at the same time. It's like having a team of workers instead of just one.
Mm-hmm. So it's kind of like dividing and conquering that data, right?
Exactly. Much faster that way.
Yeah.
And then finally, for really large-scale projects, the article talks about, using cloud computing resources and job queues to really manage that whole workflow and make sure everything's running smoothly.
So that's kind of like, If you're really serious about web scraping, taking it to that next level.
Yeah, for when you're, building a business around it, or you really need to scrape a lot of data consistently.
Okay, so now that we have a sense of like, the high level overview of what modern Ruby web scraping looks like, the article gets into this whole section about setting up your environment, before you even write a line of code. Why is that so important?
So, imagine trying to build a house without first making sure you have the right tools and materials and a solid foundation, right?
Right. Makes sense.
Setting up your Ruby environment properly is kind of like that foundation for your scraping project. It makes sure that you have all the right versions of Ruby and the gems you need, all working together harmoniously.
And they specifically recommend using something called a Ruby version manager, RVM, right?
Yeah, RBM is really helpful because it lets you have different versions of Ruby installed in your computer at the same time, and you can easily switch between them. This is really important because different projects might require different Ruby versions, and you don't want them to conflict with each other.
That makes sense. And they even give the command for installing RVM
Yeah.
curl-ssl https://get.rvm.io --bs stable. And then to install Ruby 3.3.0, which is the current stable version as of now, they say RVM install 3.3.0.
Right. And then they also recommend creating a separate gem set for your web scraping project. And you can do that with the command RVM, use 3.3.0 at scraping create. Now, gem set, you can think of it like a container for all the gems, the libraries that your specific project is going to use.
So it's kind of like having, different toolboxes for different jobs.
Exactly. You wouldn't want to use a hammer when you need a screwdriver.
Right. And then the article moves into, okay, here are the essential Ruby gems that you absolutely need for modern web scraping. They list, Nokogiri, which we've talked about already, version 1.15.5 or later. HTT Party, also mentioned that, version 0.21.0 or later.
And then we have a few more specialized ones. So Selenium WebDriver, that's version 4.16, and that's a powerful tool for automating web browsers. This is especially important when you're dealing with websites that are very interactive or have a lot of JavaScript that changes the content dynamically.
So it's like having your code actually control a web browser, right?
Exactly. And then there's Ferrum, which is specifically designed for automating the Chrome browser, and that's version 0.13. And these are really helpful because sometimes you need to interact with the website just like a human would, click buttons, fill out forms, wait for things to load to get the data you need.
So Ferrum is like that really focused, specialized tool just for Chrome?
Yeah, if you're working with Chrome, that's the one you want. And then they also list async HTTP version 0.60.2. And that's for making asynchronous HTTP requests, which is a fancy way of saying making multiple requests at the same time without waiting for each one to finish before sending the next one.
And so that really helps to speed up the whole process, right?
Yeah, it's like imagine you're cooking a meal and you can chop vegetables while the water's boiling at the same time rather than waiting for each task to finish before starting the next.
Okay, I like that analogy. And then finally they mention OJ, which is for fast JSON parsing, version 3.16.
Right. So JSON, that's a very common format for data on the web, so you can encounter it a lot. And OJ is just a really efficient library for processing that data quickly. And all of these gems, they're typically listed in a file called a gem file. And that's how you tell Ruby which libraries your project depends on.
So it's like a recipe card for your Ruby project.
Exactly. That's a great way to put it.
Okay. So we've set up our environment, got all our tools in place. Now we're ready to actually start scraping. The article jumps into a section about modern approaches to web scraping, and the first one they talk about is intelligent request handling, which sounds like it's a lot more than just, sending a request and hoping for the best.
Yeah, there's definitely a lot more nuance to it than there used to be.
So what do they mean by intelligent request handling?
So one of the key things here is using this gem called retryable, which basically makes your code more resilient to errors. So, sometimes when you're scraping, you might run into a temporary issue. The website might be slow or there might be a network hiccup, something like that.
The internet being the internet.
Right, exactly. And so what retryable does is it allows you to automatically retry those failed requests a certain number of times with increasing delays in between. So it's like saying, okay, I'm going to try this again in a little bit, and if it still doesn't work, I'll try again a little later, and so on. And they even mention specific error types like httparty.error or timeout.error, and those are like signals that, hey, maybe it's worth trying again. So instead of just giving up, it keeps trying until it gets the data or reaches a certain limit of attempts.
I see. So it's like building in that, that persistence, that ability to kind of, ride out those temporary storms on the internet.
Exactly. And it makes your scraper much more reliable in the long run.
And then they talk about generating realistic headers. Now, I think a lot of people, they don't even know that headers exist. So can you kind of explain what those are and why it's important for them to look like they're coming from a real person?
Yeah, so every time you visit a website, your browser actually sends a bunch of extra information along with the request for the page. And this information is contained in headers, and it's kind of like a digital fingerprint. It tells the website, what browser you're using, what operating system you're on, what language you prefer, all sorts of things.
So it's like, almost like the metadata of the request.
Yeah, exactly. It's information about the request itself. And websites can actually look at these headers to try and figure out whether the request is coming from a real person or a bot.
I see. So if your headers look like they're coming from, some kind of automated script, that might raise red flags.
Right, because they don't want bots scraping their data, generally speaking. So what you want to do is make your scraper's headers look as close to a real browser's headers as possible. So, you might use a common user agent string, which identifies the browser and operating system, and you can even set headers for things like accepted languages and encoding types, just like a real browser would do.
So it's kind of like, putting on a disguise for your scraper.
Yeah, blending in with the crowd, making it look like just another regular user.
So the website hopefully doesn't get suspicious and block you.
Exactly.
Okay, cool. Now moving on, they talk about concurrent scraping with modern Ruby features, and they specifically call out Ruby 3.x. So what's so special about these newer versions of Ruby when it comes to scraping?
Well, Ruby 3 brought in some really cool improvements for how it handles concurrency, which is basically being able to do multiple things at the same time. So instead of your code just going step by step, it can now actually work on multiple parts of the problem simultaneously.
And they mentioned specific gems like async and async HTTP, right?
Right, those are great libraries that really let you take advantage of those new concurrency features. And they give this example of using an async.barrier, which is like a way to synchronize multiple tasks so you can process things in batches. So you might say, okay, I want to scrape these 100 URLs, but I'm only going to do 5 at a time concurrently. So you send out those 5 requests, wait for them to finish, then send out the next 5, and so on. And that's much faster than doing them one at a time.
I see. So it's kind of like, having that team of workers again, but now you're giving them, smaller chunks of work at a time.
Right, just to keep everything organized and efficient.
Now, the next section they dive into is modern HTML parsing techniques. So we've talked about Nokogiri already, which is, that powerful tool for understanding the structure of web pages. What are some of the more up-to-date ways of actually using it to extract the data you want?
So one of the key things here is they recommend using nokogiri.html5.parse, HTML. Now, HTML5, that's the latest version of the HTML standard, and this specific parsing method is designed to be more forgiving of errors and inconsistencies that you might encounter in real-world HTML, which can be messy sometimes.
The internet again.
Right. Websites aren't always perfect. So this helps Nokogiri to make sense of that HTML, even if it's not perfectly formatted. And then they also talk about using modern CSS4 selectors. Now, you probably know CSS selectors from styling web pages, making them look pretty. But you can also use them to target specific elements within the HTML structure. And CSS4 introduced some really powerful new selectors that can really help you pinpoint exactly the data you're after.
Yeah, they gave an example, data-tested product card, which is kind of a mouthful.
It is, but it's really powerful.
Yeah.
So data tested, that's what's called a custom data attribute. So developers can actually add these attributes to HTML elements to kind of give them a unique identifier. So if you're trying to scrape a product page and the developer has added this data tested attribute to the product card element, you can use that selector to grab just that specific element, no matter where it is on the page.
And they also gave some examples of how you would actually extract the data. So for example, to get the title of a page, you would use not title. To get the price, you might use dot price. But then they mentioned having to maybe write some code to clean up that price data, like remove currency symbols or commas.
Yeah, that's where you might write a little helper method, maybe called something like parse price, to format that data in a way that you can actually work with. And then there's this really cool selector that has .indes stock. This one's really useful for checking if an element contains another element with a specific class. So, for example, if you're scraping a product page and you want to see if the product is in stock, you might look for an element that has the class in stock inside of it.
So you can really get quite specific with what you're trying to grab.
Absolutely. And the more specific you can be, the more reliable your scraper will be in the long run.
Okay, so we've covered the basics of sending requests, handling errors, parsing HTML, but as you mentioned earlier, modern websites aren't always so easy to scrape. They often have all these anti-scraping mechanisms in place. So how do we handle those challenges?
That's where things get really interesting. One of the big challenges nowadays is dynamic content, which is basically content that is loaded after the initial page load using JavaScript. So if you just try to scrape the initial HTML, you might be missing a lot of the data.
Right, because a lot of websites are built using frameworks like, React or Vue.js, where a lot of the content is generated on the client side, not on the server side.
Exactly. And so to handle this, the article introduces Ferrum, which we talked about earlier, that tool for automating the Chrome browser.
Mm.
And it specifically mentions using a headless Chrome browser, which is basically a Chrome browser that runs in the background without a graphical interface. So you can control it programmatically, but you don't actually see a window popping up.
So it's kind of like having a ghost browser working behind the scenes.
Yeah, that's a great way to put it. And the process basically involves using Ferrum to go to the URL, just like a normal browser would, but then you have to wait for the dynamic content to load. And they give a couple of ways to do this. One is using it browser.network.waitForIdle, which waits for all the network activity to settle down, indicating that the page is probably finished loading. And another way is to wait for a specific CSS selector to appear, which might be a sign that a certain part of the page is loaded. So you could do something like at browser.css.content-loaded.wait, and that would wait until an element with the class content loaded appears on the page.
And once you know that dynamic content has loaded, then you can go ahead and start extracting it, right?
Exactly. You can use the same CSS selectors and techniques we talked about earlier, but now you're working with the fully loaded page with all the dynamic content in place. And then, crucially, they emphasize the need to properly close that headless browser instance using @browser.quit. You want to make sure you're cleaning up after yourself and not leaving a bunch of ghost browsers running in the background.
Yeah. Otherwise, you could end up with a whole horde of them, eating up all your computer's resources.
Right, and that's not what we want. Okay, so moving on to another challenge, we have rate limiting and proxy management. Now, we touched on proxies earlier, but can you explain why rate limiting is so important and how it all ties together?
Yeah, so as we talked about earlier, websites don't generally like it when you bombard them with tons of requests all at once. It can overload their servers and make things slow for everyone else. So many websites have rate limits in place, which is basically a limit on how many requests you can send within a certain time frame.
And if you exceed those limits, well, they might block your IP address, which means you can't scrape from that IP anymore. So rate limiting is all about being a good citizen, making sure you're not overwhelming the website with requests.
It's kind of like, if you're at a buffet, not taking all the food at once.
Exactly, leaving some for everyone else. Now, proxy management comes in when you need to make a lot of requests, maybe from different geographical locations, or you want to spread your requests out to make them look less suspicious. So you can use a pool of different proxy servers to distribute your requests so it looks like they're coming from different places.
And the article specifically mentions using a connection pool to manage this pool of proxies.
Right. So a connection pool is basically a way to keep track of a bunch of connections to different proxy servers. And you can set a pool size, which might be, for example, 10, which means you'll have 10 active connections at a time, and your code can just grab a connection from the pool, send a request, and then return it to the pool when it's done. And this way, you can cycle through your proxies, making sure you're not using the same one too often and getting blocked.
So it's like having a team of, delivery drivers who can each pick up a package and deliver it and then come back for another one.
That's a great analogy.
All right. Now, to really bring all of this together, the article gives a real-world example, e-commerce price monitor. So what does this example show us?
So they walk through the basic structure of a price monitoring system that you might build using all the techniques we've talked about. So you would have a main class, maybe called something like Price Monitor, and it would have all the logic for, managing the URLs to scrape, sending the requests, parsing the data, and saving the prices to some kind of storage.
So it's kind of like the brains of the operation.
Exactly, the conductor of the orchestra.
Mm-hmm.
And then you would have a browser pool class, which would manage those headless Chrome browsers that we talked about, so you can scrape those dynamic websites.
Yeah.
And you would probably have a storage class to handle saving the price data, maybe to a database or a file. And the whole thing would be set up to run asynchronously, meaning it can handle multiple tasks at the same time, and it would incorporate rate limiting to make sure you're not hammering those websites with too many requests.
So it's really a practical example of how all these pieces fit together to build a real-world application.
Exactly. It's not just theory anymore. It's putting it all into practice.
Now, the next section is all about best practices for production scraping, which I guess That's when you're no longer just playing around, you're actually building something you want to rely on, right?
Yeah, this is when you're taking your web scraping project from, a fun experiment to something that needs to be reliable, scalable, and maintainable over time.
So what are some of the key things they highlight in this section?
So one of the big things is monitoring and maintenance. This is all about making sure you have a good understanding of how your scraper is performing and being able to quickly identify and fix any problems that might arise. So they talk about setting up logging so you can track what your scraper is doing. And they also mention error tracking. So if something goes wrong, you get notified and can fix it.
So you're not just, launching your scraper and hoping for the best. You're actually keeping an eye on it, making sure it's behaving itself.
Right. It's like having a babysitter for your code.
Exactly. And they also talk about monitoring the health of your proxy servers, right?
Yeah, because if a proxy goes down, you need to know about it so you can replace it or switch to a different one.
Yeah.
And then they also mention using performance metrics to track how efficiently your scraper is running. So you might measure things like how long it takes to scrape a certain number of pages or how many requests you're able to send per minute.
So it's kind of like, keeping track of the vital signs of your scraper, making sure everything's running smoothly.
Precisely.
And then there's the whole aspect of data quality and validation, right? So it's not enough to just collect a bunch of data. You need to make sure that data is actually what you expect it to be.
Absolutely. You can have all the data in the world, but if it's garbage, it's useless. So they really emphasize the importance of validating your data, making sure it conforms to a certain structure and data types. And they recommend using a dedicated data validator class, which is basically a piece of code that checks your data against a set of rules, a
A
schema.
blueprint for your data, right?
Exactly. So your schema might say, okay, the title field has to be a string, the price field has to be a number, the URL field has to be a valid URL, and so on. And if your data doesn't match those rules, the data validator will flag it so you can fix it.
So you're kind of like, putting your data through a quality control check before you actually use it.
Exactly. Making sure it's good enough to work with.
Okay. So now that we've covered, the present of web scraping with Ruby, the article takes a look into the future. What are some of the emerging trends they see on the horizon?
Well, one of the big trends they highlight is the increasing integration of artificial intelligence, or AI, into web scraping. So instead of just relying on simple rules and selectors, you can actually use AI to understand the meaning and context of the data you're scraping. So you can imagine an AI-powered scraper that can actually read a news article and extract the key facts and figures rather than just grabbing chunks of text.
So it's kind of like moving beyond just, the syntax of the data to actually understanding the semantics, the meaning behind it.
Exactly. And they also talk about the continued rise of headless browsers, which we discussed earlier. As websites become more and more complex and reliant on JavaScript, the ability to automate a real browser becomes even more important. And they also foresee the development of more advanced techniques for handling anti-bot technologies as websites get better at detecting and blocking scrapers. So it's going to be an ongoing cat and mouse game.
Like an arms race between scrapers and websites.
Exactly. And finally, they talk about improvements in Ruby's own capabilities for handling parallel processing, which will make scraping even faster and more efficient.
So it sounds like, Ruby's going to be keeping up with the times.
Absolutely. It's a language that's constantly evolving and improving.
Now, the article takes a really interesting turn with a section called From the Field, Developer Perspectives on Ruby. So we're stepping back from the technical details of web scraping for a moment and looking at the bigger picture of where Ruby fits into the world of software development.
Yeah, this is where we get to hear from real-world developers about how they're actually using Ruby in 2025.
Mm-hmm.
And one of the main takeaways here is that Ruby is still very much a relevant and valued language, even though it might not be the most hyped up language right now.
Right. It's not the new kid on the block anymore.
Exactly. But it's still going strong, especially in certain areas like web development. And they point to companies like GitHub and Shopify, which are huge companies, and they still rely heavily on Ruby, especially the Ruby on Rails framework.
And the developers, they quote, they seem to really appreciate the focus on developer productivity and the readability of Ruby code.
Yeah, those are definitely some of the key strengths of Ruby. It's a language that's designed to be enjoyable to work with and to produce code that's easy to understand and maintain.
And then they bring up an interesting point about the job market, which is that there might not be as many job openings specifically for Ruby developers compared to, say, Python or JavaScript, but there's actually a huge demand for experienced Ruby developers.
Right, so if you're really good at Ruby, you can command a high salary, but it might be harder to break into the field if you're just starting out.
So it's kind of like a high barrier to entry, but once you're in demand.
Exactly. And they also talk about the ongoing evolution of Ruby, with the release of version 3.x and Rails 7, which brought in some significant performance improvements and modern features.
So Ruby is keeping up with the times.
Definitely. However, they also point out a concern about the growth rate of the Ruby ecosystem compared to some other languages like Python, especially in areas like machine learning and serverless computing.
So while Ruby is still great for web development, it might not be the best choice for every single task.
Right. And they talk about Ruby's role in technology education and how its elegant syntax and the convention over configuration philosophy of Rails make it a great language for learning the fundamentals of programming. But they also acknowledge that this same philosophy can sometimes feel restrictive for very complex projects that require more flexibility.
So it's kind of like a double-edged sword.
Yeah, every tool has its strengths and weaknesses.
Okay, so to kind of wrap things up here, what are the key takeaways from this deep dive into modern web scraping with Ruby?
Well, I think the biggest takeaway is that web scraping is not as simple as it used to be.
It's not just pointing your code at a website and grabbing some text anymore.
Right. You need to be smart about how you handle requests. You need to understand how to deal with dynamic content and anti-scraping mechanisms. And you need to be thinking about things like rate limiting and proxy management.
And we've seen that Ruby, despite being a somewhat mature language, is still very capable of handling all these challenges.
Absolutely. It has a rich ecosystem of gems that provide all the tools you need, and the language itself is constantly evolving to keep up with the demands of modern web scraping.
And beyond just scraping, we've also seen that Ruby remains a relevant and valuable language, especially in web development, where its focus on developer productivity and its mature ecosystem are highly prized.
Exactly. It might not be the flashiest language out there, but it's a workhorse that gets the job done.
So I guess the final question is what does the future hold for Ruby and web scraping?
Well, that's an interesting question. We've seen some of the potential trends, like the increasing use of AI, the rise of headless browsers, and the development of more sophisticated anti-bot techniques.
And it seems like Ruby is well positioned to adapt to these changes with its focus on developer productivity and its evolving ecosystem.
Absolutely. I think we can expect to see some really interesting innovations in the coming years as Ruby developers continue to push the boundaries of what's possible with web scraping.
So it's an exciting time to be in this field.
Definitely.
Well, this has been a fascinating deep dive. Thanks for joining us, and we'll see you next time.
Thanks for having me.
And to all our listeners out there, if you're interested in learning more about Ruby and web scraping, the article we discussed mentions a few resources: Nokogiri's advanced search tutorial, the documentation for Ferrum, and of course, Ruby's official documentation. Those are great places to start. Thanks for listening.
Happy scraping.